Have you ever stopped to think about what's really happening when a program interacts with a website? When some piece of code has to click a button or fill out a form for you? Well, there is a fascinating, kind of secret world of commands happening just beneath the surface. So today, let's pull back that curtain and see how it all really works. So let's start with what seems like a simple question. How does a computer actually click a button on a web page? I mean, it doesn't have a little robot arm with a mouse, right? So what's actually happening? What's the command? On the surface, you'd think it's a pretty straightforward two-step deal. First, the program has to find the exact button on the page. Then, it just sends a simple click command. Find it, click it. Seems easy enough, right? Well, yeah, that's what it looks like from our end. But in reality, there's a hidden translator working behind the scenes. That simple click command, it isn't actually what's talking to the web page. There's a middleman. Think of it like this. The program is speaking one language, sending its simple click command. But the browser, it speaks a completely different language. Its native tongue is JavaScript. So that command has to be translated into JavaScript before the browser can understand what to do. Now, most of the time, this translation works perfectly. It's seamless. But every once in a while, you get a little glitch in the matrix. The command gets sent out, but for a whole bunch of reasons, that translation into JavaScript, it just doesn't happen. The message gets lost. It's like a dropped call between the program and the browser. And when it fails, developers get hit with this really frustrating roadblock. It's called the element intercepted exception. And trust me, it's one of those errors that can just bring an entire automated process to a grinding halt. So what's actually happening here? Well, in short, something on the web page itself, maybe it's a cookie pop-up or an ad or just the way the site is built, is physically blocking that standard click command. And because it's blocked, the JavaScript that was supposed to run never even gets a chance to start. So the program just stops. This all leads to a really cool engineering problem, right? If the front door is blocked, how do you get your message inside? How do you click a button that's basically refusing to be clicked? Well, the answer is actually pretty elegant. You stop using the translator, and you start speaking the browser's native language directly. And this is where our hero comes in, the JavaScript executor. You can think of it as a special tool, kind of like a universal translator, that lets a program send raw JavaScript commands straight to the browser. It completely skips that middleman we were talking about. And the difference is huge. The standard way, you've got the program talking to the translator, which talks to the JavaScript, which then talks to the browser. But with the JavaScript executor, that middleman is just gone. It's a direct line, program to JavaScript to browser. It's really like the difference between sending a request through a secretary versus having the CEO's direct phone number. You get a clean, direct line of communication right into the browser's control room. But here's where it gets really cool. This direct line isn't just a workaround for broken clicks. It actually unlocks a whole set of new abilities, web superpowers, if you will, that the standard commands just can't do. So, beyond clicking those unclickable buttons, you can now type into really tricky text boxes. And maybe the most interesting one, you can take precise total control over how a web page scrolls. Okay, so scrolling is a really unique problem. You know that scroll bar on the side of your browser? It's not actually part of the website's code. It belongs to the browser itself. That means a normal program can't find it or click on it like it would with a regular button. But with our direct line, with JavaScript's executor, we can just talk straight to the browser and tell it exactly how we wanted to scroll. So just how much control do we get? We can get incredibly precise. I mean, we can literally tell the browser, hey, scroll down exactly 1,500 pixels from the top, and it will do it. Pixel perfect every time. And that control goes way beyond just picking a number. You can tell it to scroll by a specific pixel value, like we just saw. You can also tell it to keep scrolling until some element way down the page finally comes into view. Or you can just say, you know what, just take me all the way to the bottom. It gives engineers total command. And it's not just about scrolling. That direct line into the browser's control room also lets a program adjust the page's zoom level whenever it wants, setting it to 50%, 80%, whatever is needed. It's another level of control that you just don't get with standard methods. Okay, so this is all really cool, nerdy stuff. But why does any of this matter to you, the person just using the web every day? Well, what you see every day is a smooth, seamless experience where things just work. But what you don't see is this hidden layer of commands and workarounds and all this clever problem solving going on just to make that happen. Engineers are using tools like this every single day to make sure your experience is even possible.
And that's really the key here. This isn't just some messy hack. It's an elegant engineering solution. It's about recognizing the limits of a tool and then figuring out how to speak the web's native language to build something better and more reliable.
It really makes you wonder, doesn't it? The next time you're just clicking around on a website, think about all of the invisible commands, all the secret, direct lines of communication that are silently working in the background to shape every single moment of your experience.